and we are going to start today with the first day and continue hopefully Sunday for the second day of the workshop. So we will not lose more time and just go forward. I guess everyone has the slides that I have prepared and sent yesterday. So everyone has gone through them. We are going to start from the first slide and go forward and check if everyone has concern or any question about what he read. You can just like take it step by step and try to explain everything. Just put this here. Sorry, someone doesn't have the slides. Okay, give me a second. Let me just upload it for you if you don't have it. Oh, okay. So everyone has the slides and we can start, right? Cool. So welcome to the Advanced Guide to Finding Code Bugs. So before we start, who am I? My name is Hussein. I'm Lebanese. I live in Ivory Coast in Africa. I've been in the bug bounty field since 2014, late 2013, and I've been hacking for more than 10 to 11, 12 years now. I've been hacking on Buckroad, I've been hacking on HackerOne, I've been hacking on external programs too on bug bounties. And I'm going to try to share with you what I've learned along my journey and what are the techniques I use mostly. So of course we can't like cover every aspect of bug bounty, but we're going to try to get in depth into the most important parts of the things. So let us start just forward. So table of contents. We are going to explore some of the OWASP top bugs. We are going to check some real world example reports that I reported to bug bounty programs. We are going to check like what is the methodology to think outside the box. So what can you do when you find something? What are the thoughts that should come in your mind once you end up finding a functionality, and how you should approach a potential vulnerability? And we're just going to give like thoughts on every aspect of vulnerabilities and bug bounties. So we're going to start with SQL injection. We have, for every bug, we're going to have a little definition, and we start right away as this is not a beginner workshop. So SQL injection. SQL injection attack consists of insertion or injection of SQL query via the input data from the client of the application. In fact, SQL injection have always been one of the most used attack ever. So I guess everyone knows about SQL injections. SQL injections are like one of the top 3 of the most used vulnerabilities in hacking, and are also like the most critical you can get, because with SQL injection you can do many things. So first, with SQL injection you can retrieve data from the database. With SQL injections you can inject data into the database. With SQL injection you might end up having remote command execution if the user is a database administrator. So with SQL injection there is many things to be done. But how do you find SQL injections easily? No, I won't say easily, but like the good ways, the ways I use, the places that people don't usually explore. So let's go. How to test for SQL injections? There are multiple ways of testing for SQL injections. One of the most known is appending a single quote to a parameter / input and look for errors in the web page. Everyone knows this technique. You just come, you put single quote and you wait for SQL injection error and you're good. But it doesn't happen always like this. So you have many different types of SQL injections. You have blind SQL injections. You have Boolean based SQL injections. You have normal SQL injections. So it doesn't just work like I'm going to put a single quote and wait for it. And especially in bug bounty, the bug bounty fields. So the bug bounty field is the field where people are hacking on targets days and days after days. So you are never going to end up testing a website that no one has hacked on before. You should suspect that in case there was an serial injection with a simple single quote, someone should have found it like way before you. It's impossible that I've never had this luck to just come on a website, try to do my bug bounty session and just put a quotation mark and yeah, I have a SQL injection. It doesn't work like that. So there is many different characters you can use to test for SQL injections. We talk about the single quote, but you can also try to inject some weird chars to the inputs. So for example, double quotes, you have this, the markdown thing, you have this chars you can try to inject and see if there is any error or any debug page that gets activated. Let's go forward and check later. As we said, SQL injections can be found everywhere. One should test for SQL injections in get and post parameters sent by the application, but not only. You have to test for SQL injection on headers, such as accept language. You might get surprised. So funny, but it happened like, let's say 2 weeks ago, I was testing a website and I have this website and I'm checking on Pursuit and I've seen the accept language parameter that is getting set like on every request I do to the web application. So it's not like typical to just see an application that is going to just set accept language, accept language. I went forward and took the application language from the headers the website was setting to me, and I put it in my request, and I tried to play with it a bit. And after some tries, I ended up finding SQL injection on this header. So this is like the most uncommon thing you can find, finding SQL injection in accept language header. You also have to test for SQL injections on authentication forms. But not only, you have to test for SQL injection on path-based inputs, such as, for example, when you have API/user/one, just don't to assume that the ID is not getting like passed through a DB. You have to assume that it might be vulnerable. So you can just try to inject in the path. So let's say that you have, for example, let's say that you have, for example, how to do this one. Yeah. If you have /API/user/one, for example, you have to try to inject here, you know? So just like you will do for like parameter equal value, you're just going to test like that and double quote and start testing it manually. Just have to do the same for for the directory based. So this is something that not many people do. People just assume SQL injection exists on parameters. No, you have to test for everything that you can think about that is going to get passed to a database. Let's see. Yeah, sorry, we are here. Okay, so let's see some real world example and reports. Case one, blind SQL injection via get parameter. So I was testing a web application in scope for program on HackerOne. Upon visiting one subdomain, I look at my pub history and I found this part request being made. So this parts request is something that you typically see every day. Just a post to login with the language code parameter being set here, and mod and melden, which means like login, I guess in Dutch, and so password and user ID, which is being set by the application. The first thing to try is to append a single quote to each parameter in the request. But as I said, this never, like almost never works. So sadly, this led to nothing. After further investigation, I found out that the language code parameter that is here was vulnerable to blind SQL injections. So why? Appending one and this payload to the language code parameter caused the application to delay the response time by 9 seconds. So there are some SQL injection payloads you can find like on GitHub, you can find even on Burpsuit default word list. So you have like a ton of SQL injection payloads, and you can just, if you suspect that an input is vulnerable, you can just like import the parameters to the payloads to Burpsuit and Truder and just run them against the input. And you can, even in Burpsuit, like you can do everything you need. So you can check the response time, how much time did the response take to respond. So you can test for blind SQL injection. You can see the web page content after you send the request. So it's very handy tools to have. So takeaway, don't look only for SQL injection via single quotes, which return errors. Test for blind injection as well. These are more widespread and less detected by other hackers. So this is a report. As we said, it's a blind SQL injection where we can set any time delay, and the application was returning the response after the time we set. Case two. If anyone has questions throughout the course, please just drop them in the chat and I can answer them. Just checking if everyone is following. Is my connection good to you?
Yes, everything good.
Okay, all right. Thank you. So case two, Boolean-based blind SQL injections via GraphQL parameter. So everyone, you know, GraphQL have been implemented. We can see in the last couple or last 3-4 years, we have seen many websites started adapting GraphQL, which is kind of endpoint for us, for hackers, where we can get schemas and try to retrieve data from it. But not also, people always go for like IDORs on GraphQL requests, but you can test for many type of vulnerabilities. You can test for SQL injections. You can test for remote command executions. You can test for path traversal in GraphQL requests. So you can typically test every vulnerability that you have in mind. A couple of weeks ago, I decided to hack on a bug bounty program which is public and had more than 1,000 resolved reports. While browsing the application, I found a request that was being made to a GraphQL endpoint located at website/GraphQL. The first thing that comes in mind is GraphQL introspection query allowed? Can I find more methods to test either any vulnerability in the methods invoked? So I'm going to give tips as soon as we advance. I know everyone has I myself, I've had much trouble with GraphQL and with GraphQL in general when everyone started testing for it. So I didn't understand how things works and how should I proceed to be able to construct a good GraphQL request and how I should learn it. So there is this Burp Suite extension, which is called ENQL Scanner. I guess some people might know about it, some might not know about it. So you can just get it from GitHub. It's from the INSEC team. And this is an extension that whatever GraphQL link you add, in case the GraphQL endpoint accepts introspections, is going to like build for you a schema. You can just like use, send to repeater, and you can test. Just add your cookies. Let me see if I can get a public GraphQL. Let's see here. Okay, let's see what happens. So as you have seen, this is a GraphQL endpoint like atlassian.io/GraphQL. All I had to do is just paste it here and press load. And so we have the mutation queries that have been built for us. And we have also all the queries which have been built for us. So you just have to like right click, send to repeater, and it's all set. Just have to start testing. So this is something that you have to save because it's not included in the slides. This is stuff I'm going to just like talk about every time we go forward. So this is very important. I myself I can test GraphQL endpoint without this extension because it's very hard to construct the requests if you don't have all the knowledge around it. You can go forward here and up. Oh, why does it go back? So we were here. So while building application, I found a request that was being made to GraphQL endpoint located at website/GraphQL. The first thing that comes in mind are, is GraphQL introspection query allowed? Can I find more methods to test? Is there any vulnerability in the methods invoked? Let's go forward. First thing, trying introspection query on the GraphQL endpoint. So as I have shown you, just like 5 minutes, some seconds ago, you can use ENQL scanner on Burp Suite to test for introspection. And this one, luckily it was working. The request was successful and the server responded with all the available GraphQL methods. One caught my eyes really fast. So there was the GraphQL method that was called Polaris Connect App by Client ID. And it says in description, this operation is in beta. This field is currently in beta phase and may change without even notice. And a bunch of other information about the endpoint we are going to check. So crafting the request, as seen in the previous slide, the application needs us to set the custom header for the server to process our request. You can see here X experimental API Polaris v0. So I just set this header on my GraphQL, how to say, endpoint. And you can see here PostgreSQL, there is this query. We have set the header that the server was needing, and we just get a 200 OK and with some data. So our request is well constructed and well formed, and we can go forward and start searching for vulnerabilities in the methods. So we had this. It says query Polaris Connect app by client ID, OTH client ID, authorization client ID 1. Okay, so I have tried some scanning on this specific parameter authorization client ID, and after some time, you can see that as injection SQL injection led to something really bad. So when I tried this blind SQL injection, which basically is to test for the existence of the vulnerability, if I set the parameter value to or not one equal one, and for example, anything equal anything, I was getting no error. It's not, I was not getting any error because in fact, there is no thing that is wrong in my SQL query. So one equal one and this equals this. So going forward, in case I change this value of the parameter, so injection the SQL payload 14 or not, 1 equal 2. If I change 1 to 2, I was getting this error which says connect application fetch error with a lambda sign and case 1006. And so it says error code getaway time out. So this is very suspectful. So if you have like 1 equal 1, you get no error. You put 1 equal 2 and you start getting errors. So of course, there might be something that is very fishy. What I usually do when I suspect that there is a SQL injection vulnerability on a parameter, after doing some manual tests, I just directly import the request to SQL map. So SQL map is a really powerful tool for detecting and scanning SQL injection. Yeah, sure. Of course. Sure. Do you want us to just go forward with the questions, or do you prefer we treat them at the end? Let's see. So there is this tool for Shivam. There is a tool called Atlas. Atlas is a tool which basically takes SQL injection tamper scripts, and with it you are going to bypass the WAF like Cloudflare and all. So for example, let's see here, if you type Atlas SQL map, so Atlas is a quick SQL map tamper suggester. You know, in SQL map, you have tamper scripts, and tamper scripts are, for example, scripts which are going to change some chars to other chars to bypass the WAFs. So Atlas is a tool that takes your vulnerable link, and it takes SQL map, and it's going to like find the perfect tamper script for your WAF. Of course, it doesn't work every time, and sometimes you have to go manually and you have to start testing it by yourself and trying to find a good bypass for each WAF. So it might be custom sometime, but usually this tool works really well for me with SQL map. And so as I said to Shivam for the SQL injection, so first thing I will try to do is just a single quote. Second thing I'm going to try to do is just putting some random chars and checking for potential errors or time delay or something that's going to happen. One, and yeah, it's a good time to talk about it. So there is one trick or one thing that worked for me in the past week for SQL injection. So I've had a similar request. It says like host slash, for example, let's say script.php id equal test, and we had like, for example, username. Yeah, let's go. You can ask as many questions as possible. You have time. Don't be shy. So I had a website which was doing something like that. We had hosts that script.php, id equal test, and username equal g. And one trick that worked for me to detect an SQL injection is inputting this weird character. How to put the percentage, sorry, on this keyboard. Yeah. So I just, this run, okay, so it's here. Let's try decode. So this is not even decodable. So this is a chart just like, you know, FF and stuff. So most of the time application don't have, if they don't have the proper processing for this kind of input, it might just like break something and throw an error. So after I put this input here, there was a debug log which showed me like, for example, insert insert id equal test and username equal g, something error because this char is not valid. But what was interesting is that in this error log, it says, for example, it was something like insert id virgule username name password into values. It says it says, so we have id test, username which we don't have, we have here, sorry, name which we don't have in this request, so it was empty, and password which was empty too. So it was something like that. So this didn't trigger an SQL injection, but when I did input this char, it showed me that there are other parameters in the request that are ID, username, password. So I've had ID and I had username, but I didn't have name nor password. So basically, this ID parameter was not vulnerable to SQL injection. I've tried everything and it was not vulnerable. But after I've seen this parameter here, I was just able to add it up here, and this one was vulnerable. So by making the application through an error log, I've had the opportunity to see other parameters that are not, that I don't know about, which were indeed vulnerable to SQL injections. So for Atlas, as we were talking, Atlas here, you can see what it says. Atlas is an open source tool that can suggest SQL map template script to bypass WAF, IDs, IPs. So let me just try to drop in the Slack for you, maybe. Can I pass it here? Yeah. So we've had this one, and we've had ENQL scanner burp suite. Okay. So if anyone needs the tools, you can find them on the Slack channel. So let's see some use cases of Atlas. Basically, you're going to input to run the script Python Atlas with the link you suspect is vulnerable to SQL injection but has a WAF behind. And you input the payload that triggered the WAF to ban you or give you an error. So for example, if you were doing website slash ID equal, for example, let's say it was test, and you did like, for example, and 1 equal 1, ta, ta, ta. If you had this, so you are going to use Python Atlas um, dash dash the link. So you just, sorry, put it here. And you include the payload that caused the error to trigger. So this is the payload which got the WAF to ban me. And when Atlas has this payload, it's going to do mutations. So it's going to try for other, for example, encoding the URL, or for example, adding some random commands or trying, and it's going to give you back a response of which tamper script is useful for your WAF case. And later on, once Atlas gives you the proper tamper script to use, you can just go to SQL map and do the SQL map basically with the tamper script parameter. So let's see here. For example, you can use post, you can use get, you can add up headers too if needed. And for example, you can see, let's see, do everyone see when I zoom like this? Yeah, I guess. So, okay. So for example, here, he put Python SQL map Python dash u, the website databases random agent. Okay, just the basic SQL map command everyone uses. And after SQL map running with him, he got potential permission problems detected, access denied. This means that he doesn't know if the parameter is vulnerable, but he knows that there is a WAF that is blocking him from going forward. So what he did is copying the payload that triggered the WAF. So we can see here, payload, price, and ta, ta, ta. So he did Python Atlas link, he put the link, payload, he put the payload, and wait for Atlas to give you back the tamper script results. So Atlas says, trying with space to MySQL dash tamper script. Okay, this is the payload that it generated. No, it doesn't work. It's still 403 with this payload. And so trying with version keyword tamper, and this is the payload that Atlas has generated. And oops, 200, okay. So this payload worked. This means that this payload is not blocked by the WAF. The WAF doesn't catch it. And so the tamper script we just used is called versioned keyword. And at this point, all you have to do is run Python SQL map, the website, the same command you just run, basically, with the parameter tamper and the tamper script Atlas found here, which is versioned keyword. So I hope this makes sense to everyone testing for SQL injection behind WAFs and behind Cloudflare and all. Sorry. So sometime you will have, yeah, SQL map is a very powerful tool. I had a document about SQL map I have found on internet back then, which was very, 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 very useful to me. Uh, let's see if I can find the link so I can share with you. It's basically the best resource of SQL map I have found. Yeah, so I tweeted about it 1 or 2 years ago. This is it. So every time I have problems with SQL map, or I don't understand the function, or I need help with SQL map, I just go back to this SQL map encyclopedia. It contains basically everything that is needed for you to masterize SQL map. So basically everything. So for example, if we just go and search for tamper scripts, you can see tamper injection data. And you can see here Python SQL map and the tamper parameter here. So this is very, very, very a complete kit of SQL map. I'm just going to send it to you through Slack so you can have to read it if you like later on. So yeah, so Shivam, this was the first solution to your problem about WAFs and Cloudfront and Cloudflare and how to say WAFs behind a website. So the second solution for cases where you have potential SQL injection and there is a WAF that is behind and it's blocking you from making any request is you are going to try to find the real IP of the website. Finding the real IP of the website is going to make you pass by the Cloudflare and so avoid getting blocked by Cloudflare. To find the IP of a website, you have multiple methods, and you have to try all of them to get a real IP of a website. Let's talk about the easiest one first. Shivam, the easiest method to get a website's real IP behind the how to say a WAF or a proxy is just looking for IP history on internet. So if you go to IP history, you open up Vue.js and you just type like, not know why this website is here, let's check. So it's going to tell you IP history results for website you entered. So this was the IP. Then on 2014, this became the IP here. Later on 2015, this is the IP now, and so on. So for example, if you see this, and later on you see in 2014, this was owned by Konopko something, and you see Cloudflare. So you know that this IP was moved to this IP behind Cloudflare. So you know that this IP is the real IP of the website that is behind Cloudflare. And usually when you connect to the websites directly without passing by the Cloudflare, you don't have any problems anymore with SQL injections and WAFs. So this is one of the methods to get the website's real IP. Let's talk about other potential solutions to bypass the WAFs by finding website's real IP. You can go for server-side request forgeries. Let's say you have an application which takes, for example, website behind waf.com/, for example, it says it takes image.php link equal. Okay, so you have this, for example, and this is behind WAF, and you have to know the real IP of the website. So what you can easily do, just like put a website you own and wait for the website to call your external website. And in case the website is sending its the request through its real IP, you are just going to get the real IP of the website just like this. And usually websites just make the request with the real IPs. So, okay, they block what you can see, but they don't usually block when they are making external requests. It's too hard to implement. So this is something to remember. You can get real websites ID by using, for example, server side request forgeries and trying to get the IP from your logs. And let's talk about other methods to get the website real IP. You have, for example, if you go, for example, in JavaScript files, you might end up finding some informations. You can, for example, go to ASN Finder. Okay, so by, for example, by company name. Okay, I'm not sure which website it was. It was, yeah, this one. This is a very handy website. This is like the encyclopedia for, how to say, for ASNs. You can see here, for example, let's say I input, okay, let's say Facebook is behind a WAF. Okay, I'm just going to write Facebook, and this website is going to give me all the IP ranges that Facebook owns. So even if, for example, let's say Facebook was behind Cloudflare, you still have the declarations of the IP they own. So all you have to do is just take, for example, each IP range and mask scan using Nmap or anything else you love, and find the application you were hacking on inside the IP range you are checking. So I hope this one makes sense. Shivam, do you have any other question before we continue forward? Seems like Shivam fell asleep. No, he didn't. Okay, so Fawad says, do you fuzz every parameter or just some specific one? I fuzz for, I can't say that I fuzz for every parameter because you might get tired and just like being lazy to not test anything later on. So I only test parameter for SQL injections when I find the need to. For example, if I see, so just with the time, begins being more easy to know where to find the good parameters, for example. But for example, if I have a parameter that says website, for example, ID equal 7, let's say this one, okay? And you come and you input, for example, a single code, and the application tells you needs integer. Okay, so the application is clearly telling you that this is not going to pass through the functionality because we need an integer and not anything else than a number. So it's not worth spending, at least for, in my opinion, it's not worth like spending time trying to inject something that tells me, oops, what I need is a number, not what you input. So I hope this makes sense, and so you know how to choose the parameters. And also, sorry, Fawad, to adapt to it. For example, let's say that you have websites slash, let's say, username equal, let's say, for example, this, and it's getting reflected in, for example, for example, a EEE/A. Okay, so you can clearly see that this parameter username is not getting processed by the backend. It's just getting reflected on the page, on the HTML page, on the DOM. So it's not worth injecting here because there's nothing that is getting processed by the database. So just skip this kind of cases to save time. Hope this makes sense. Fawad, have I answered your queries? Okay. Anyone has questions before we go forward on SQL injections topics? Okay, so I guess we can go forward. Okay, so when do you stop on a parameter and say it's not vulnerable? So at first, before even trying to go in depth into a parameter, trying to hack into a parameter for SQL injection, I should have some signs that tell me, man, this parameter is really fishy, you know. So this one is really fishy. I have to get this feeling after doing some tests. If, for example, at some point, I don't find any way to confirm my statements that this parameter is vulnerable, I'm just going to save the request to my logs, and maybe, you know, 2, 3, 4, 5 months later, in case I get better at SQL injection, I can visit again this request and try to exploit it again. So really, it's good having a text file where you just save request and functionality you were not able to test today, you were not able to hack today, and just coming back to them 5 months later, 6 months later, when you feel like you are ready to take it again and you are ready to test it again with other perspectives because you have learned much between this time. Usually, Neo, just to add up again to my answer, usually if I can't find any confirmation that a parameter is vulnerable, and also SQL map, which is of course better than me at SQL injections because SQL map is automated. If SQL map tells me that it is not vulnerable to, and I can't find a way to confirm, I'm just going to stop here to not waste much time. So bug bounties is not about the best bug you found. So everyone that joins bug bounty, of course, there is the need to hack. There is the love to hacking and the love to trying to break stuff. But we all love money. So, but we are all looking for bounties too. So if you end up spending too much time on a parameter that is, for example, not 100% vulnerable, you're just going to waste money because every second that passed, it's like you invested time, but you didn't get anything out of it. So just focus on the thing that you are sure are vulnerable and try to exploit them till you can provide a good proof of concept. Okay, Neo. So Fawad says, what about the TomNom tool, GF patterns? Are those helpful for finding SQL injections? So I guess, Fawad, I guess these are tools for people who go for automation. This is not something that I do on my own. I don't use, I love TomNom's tool. He's a great coder and he added up so much value in the bug bounty industry, but I don't use this tool, so I can't give much information about it. So Abida says, what are the most common characters that triggered error for you while testing for SQL injection? Like you had mentioned, are there any more? Yeah, there is more. So basically, everything that is not printable by the application triggers errors every time for me. Let's talk about a few. So so there is, for example, this one we talked about. There's also this one that usually returns errors. You have also a null byte that sometimes return errors. You have just trying to insert some random characters into a parameter. So for example, if a parameter takes only, for example, numbers and you input this, if it's not well handled on the backend, it's just going to throw some debug log, which might be helpful. And there is a couple more. For example, if you go to, let's say, to any code, you have this website which takes any character you want and turns it into any code. So for example, sorry, for example, this kind of characters sometimes triggered errors for me, which helped me exploit more and more in depth my bug bounty target. Sorry, here, yeah. So you can save this one and try from today on, try inputting them when you are trying. Oh, there is something I should also tell you about that I was about to forget. So thanks, Abida, for the question. Another another thing that might trigger errors and debug logs that might help you. For example, if you have this website and the parameter ID, sometimes adding the brackets here are going to cause the application to throw an error. This happens because this is not a list. So ID is normally a single object, but you're going to input a list which is not supported by the backend. So it's going to throw an error. So you have, along with this one and other characters that you might find, everything that is not printable and is weird for the application, you can try just inputting, also adding up brackets um, just before parameters. And so this happens more often than you think, really more often than you think. Sometime when doing some bug bounty tests or hacking, you might, for example, need a single full path disclosure, a full path disclosure of the server. So for example, where is the server located at, for example, let's say slash, okay, let's say it's here. So just inputting usually, sorry from, so just inputting this here can throw some errors, which are going to lead you to just get some debug log that might help you with other exploitations such as SQL map and how to say, and for other vulnerabilities. So one thing I forgot to tell you about SQL map is that with SQL map, you can also, in case you have a successful SQL injection and the user is a database administrator, you can use SQL map to escalate the bug. So I don't know if everyone is aware of it here, But SQL map has some parameters like file read. For example, if you put file read slash password, in case the username, in case the user that you access the database is administrator, if you input this to SQL map, etc., and you put this, it's going to try to read the local file password. So you have more and more commands for SQL map like OS spawn and others, which you can see on the SQL map link I sent in this Slack. So for what says, is it good to test one parameter for different bugs like SQL, LFE, etc.? Yeah, of course. Every parameter can be vulnerable to any kind of vulnerability. So you have to test for everything where you find the need to. Don't have just to stop on one parameter and say, I'm done. No, you have to test for everything, at least if you have some time. So can we go forward? Is everyone, do you have more questions before we go? I guess, welcome, my pleasure. So I guess we can go forward. Let's see where we were. We were exactly here, okay? Okay, so we were here. And we've had the error that triggered us to launch SQL map. And so if you have like post data using SQL map or put data or delete method, don't just copy the link and add up parameters. Just save the request to a txt file and import it using the error parameter in SQL map. So you have to have the request.txt in plain text, and you can import it to SQL map easily. This makes it really time saving for everyone. So taking it to SQL map gave me access to other database to the databases which contains like informations about the tables and the columns, and I was able to retrieve data too. So this is a simple case we explored. Takeaway: look for SQL injections everywhere, even in GraphQL parameters. More people look for SQL injection in AZ spotable parameters. Go beyond it. So have it in mind. Test for SQL injections in headers. Test for SQL injections in GraphQL endpoints. Test for SQL injections in the full path of the website. So you have to test for it everywhere you feel the need to. Import the request to SQL map when you confirm existence of SQL injection vulnerability to dump databases and show impact not to dump but to list. Don't dump any database. Show impact if program allows it. Okay. So we have some labs we're going to do. Is everyone ready for the labs? We have actually, I guess, let me see here. We have around one hour and a half to go before the next before the first break, right? Because I'm not very good with timing stuff. So we can start doing the labs for SQL injections. So you all have the website http test php.vernweb.com. I'm going to give you 10 minutes to spot the SQL injections. Okay. You will have your hacking setup set. You can try to get it. Do you hear me? Okay, so everyone is on it. Okay, so try to spot the SQL injection on this lab. And the first one to solve it in the next 10 minutes will have to share his screen and show us how he approached the target. And so we can comment all together and get more tips around this. Please, if everyone is trying to inject to find a SQL injection, please reply yes in the Zoom. So I know everyone is connected and doesn't have problems with connections. Okay, thank you for your responses. Very appreciated. Neo, you're so fast, man. Give your friends some time. Let me cut my camera for 1 minute and try to fix one thing. And you all continue trying to find the SQL injection. Okay, nice. Give me 1 minute for the video. We give time to the other to try to find it. So everyone can still hear me. I'm fixing one thing. Give me some time. So does anyone need more time to try to find it? Nice, Abiva. Fawad, nice. Neo, nice. Alejandro, did you get it?
Yes.
Nice. Ome Mishra, did you get it? Luis, can you hear me? You got it too? Your mic, okay, okay, okay. So who wants to go share his screen and show us what he did? Who's down to share his screen and show us what he found? And then we can go forward together. Neo, do you want to share your screen? Yeah, sure, no problem. You can go on. You can write on a text note. How do I give you share screen? Let me see how I do. I'm not sure if you should share from your side, I guess. Okay. It's pretty easy. You should have a share screen. You should have a share screen option. Oh, so there is two people in the. Who is GB and Evran? I'm not sure. Let me see. Oh, okay. So I'm not sure how we activate it. Is it from here? No. Do we have anyone from Threadcom team? Yeah, okay. Let's do it like this. You can share the link. Everyone shares his link and his solution in the chat. Okay. Okay. Let's go and see what's up here.
Hey Hussein, do you need me to look into anything here?
Yeah, I wanted to try to. How do I allow people to share their screens?
Okay, so I think you can go to the participant section and click on more when there's a more option when you hover over their names. And I think you can allow them.
Oh, okay. So it's good. Someone, I'm not sure which of you guys enabled it, but it's good. No worries.
Okay, sure.
It's good. Not sure what's happening here. Did someone hack me? My connection is not working. Yeah, I do have internet. Let me see what's up here. Okay, so it's a bug on Chrome. So we have this here. Yes, Peter. Okay. So yeah, everyone obviously got it. So pretty easy to just spot this one just by inputting a single code. You can see the SQL injection and you can start testing for it. There's this one. You can see, Abiba, what I was talking about. So this is the trick I was talking about earlier. So giving this is going to throw an error saying us to be resource Boolean given. So this can give us more tips into exploiting what we're trying to exploit. So I didn't test on this parameter before we started, but luckily it's working, so you can see a live example. Thank you for sharing for enabling the screens. There is 2 people in the waiting room. I'm not sure if I should accept them. Okay, so let's go forward. We have more labs coming later on. Let's just take the next steps and see what we have and what we should do. So now we are going to check for XXE, also known as external entity injection. Before we start this module, does anyone have questions about everything that we've talked about? Is there anything I should develop more for you? Man, yeah, Neo, man, SQL injections are everywhere. SQL injections are still very, very common, but it's just not as easy spotable as it was in the past. So just take the tips I gave you and start testing with these tips, and hopefully you can start getting some good results. You have to. Alejandro, is there anything you want to ask before we go forward? Abida?
Yes,
T
maybe,
Zion. Yeah, go on,
maybe
man.
no SQL injection. What do you experience about that?
Sorry, I didn't get you.
Yes,
I didn't hear.
about no SQL injection. What is your experience about that?
So SQL injections, just like SQL injection, they are also common, and MongoDB. So no SQL injections, mostly on MongoDB. Also, nowadays, most of the databases you will find are MongoDB, and you will find also PostgreSQL, and SQL injections on MongoDB is also common. So, sorry, when you have, for example, there is a really good website. Let's see here. Yeah, it's working now. So here you can find many payloads you can import into Burp Suite and Reader when you have to make your test. So for example, if you just save all of them to a text file, for example, myself, I've made, let's say, a fusing folder where I have like my custom payload I have developed, and some payloads I have seen in the wilds and on resources. So for example, if you choose, I'm not sure, server-side template injection, I have a bunch of payloads. I'm just going to mass spray if I find something that is fishy using Burp Suite Intruder. So I recommend you to do the same with SQL injections and with server-side request forgery and local file inclusions and all. This might help you much in your bug bounty journey. So with NoSQL injection, it's common, but it's not that easy to spot, because with NoSQL injections, you don't have many errors that show. So it's mostly about authentications is bypass. So for example, when you can see here for bypassing the authentication methods. So if you enter, for example, sometime on, sorry, how to close this, on MongoDB with NoSQL injections, for example, you enter this equal this value and pass equal 1. This might bypass the authentication methods. So it's hard to find. It's not easier to find, but it's worth putting time. But one thing you should know is that when in case you are trying these payloads, for example, on a database that is not MongoDB on the backend, you will be just wasting your time. It's just a waste of time. You might be trying payloads and payloads and payloads and payloads and just end up getting nothing out of it, because just the database is MySQL or it's another database that is not MongoDB. So it'd be good to, what I'd recommend is having, for example, 2 or 3 entries from each SQL injection method. So you can check here, you get NoSQL injection, you take 2 or 3 payloads that might trigger errors like on MongoSQL. This is the payload that might trigger an error. Just take a bunch of a bunch of payloads, throw them into a list, and start spraying it into a custom parameter if you find anything that's fishy. And from this point of view, you might have more information about if a parameter is really vulnerable or not, and you will know which database is running on the backend based on the response you get from your scans. Did I respond to your query?
Yes, great, thank you.
Welcome. So I'm just going to paste this link too. Okay, so it's in Slack. If anyone wants to build a custom list later on for his payloads, you can just take a bunch of payloads from there and go on. So we are going to start with the second module, which is external entity injections. So external entity injection from Porttrigger, XXC is a web security vulnerability that allows an attacker to interfere with an application's processing of XML data. It often allows an attacker to view files on the application server file system and to interact with any backend or external system that the application itself can access. So this is one of my preferred attack vectors, how to say attack methods maybe, because it is a bug that is very, very, very fun to exploit. You get to think and you get to try to bypass WAFs and you get to try to exfiltrate data. So it's really interesting to see how people approach XE vulnerabilities. So if you go forward, where to find XXE? Usually you can find XXE in XML posted data. So for example, you get a website where there is a functionality that makes it post XML data to another endpoint. So you have to try to exploit this functionality. The most of the time, and what we see nowadays, is JSON post data. So you have an application on Burp Suite, which is called content type converter, which usually what it does is that it converts JSON. So if you have, for example, here, it converts JSON to XML, so you can easily. So for example, if you have this JSON, we're going to choose content type converter, convert to XML, and so it constructs a XML file, XML payload, so we can try to exploit. So in case the response to this and the response to the initial JSON payload is the same, it doesn't give an error. It means that the backend also accepts XML data. And so you can try to find XXA using the XML data that was converted from JSON. So this is a trick I usually use every time I see a JSON posted data. And so I try to exploit it further to check if it's vulnerable. So you have also, I forgot to, I didn't add it up here. You have also in SIML posted data, because usually it's like base 64 encoded with XML inside. So you have to decode and to add a payload and just encode again and post it back to the parameter that it belongs to. So the simplest test for XXE is the simple replace. Sorry, where are we? Okay. So the simplest test to confirm existence of a potential XXE is the new entity test. So basically what you do is that you have a XML posted data from the start, and you create a new entity that is going to replace the data that is posted. So we have entity to replace 3, and we call this entity back in product IG, and we have we have a 200 OK, so there is no error, and the application displays back the content of project ID equal 3. So the fact that the application accepted our XML input and processed it means that we might be able to find a XXE vulnerability on this functionality. So file reading through XML entity. We have this payload, which says doctip foo entity example system /etc/password. And so entering this one here is going to give us back the content of the local file. So this happens because we have declared the file we want to read here, and we are calling it here instead of the initial project ID. And so we are getting invalid project ID and this data. So going further, we have other payload to test for XXE. This one, the first one is XXE to SSRF test. So if, for example, you have a XXE vulnerability, but you can't hit local files, you can't retrieve local files, you can try to turn it into a server-side request forgery, where you might end up having more luck, for example, hitting AWS metadata API and stuff. So this might be really handy to try. No forward, XXE only works for XML format, not JSON format. We convert the JSON to XML to try XXE on XML data. And in case you have WAFs that are getting you blocked with this kind of payloads, you can just try to base64 on code like this payload to avoid getting blocked by backend WAFs. So let's go forward. We have some real world attack. Okay. So case 1, we have file exfiltration via external DTD. So first point, API documentation of target available at partner.stagging.redacted.com. The documentation list endpoint at JSCache swap XML at this endpoint, which takes basically XML data. The simple proof of concept. As soon as I had the endpoint and I knew it takes XML data, all I had to do is just paste back a payload, and I can see the request being made to my server. So we have this here. All we had to do is just include a simple XXE payload, and you can see that the server hits back my server here. Going forward, we have now, okay, so the application is hitting our server, is making an HTTP request for our server. This is really cool, but this is not what we want. We want to show impact, and just a simple external connection is not enough. So going forward, how do you dump files? How do you exfiltrate files from XXC vulnerabilities. So you can use external DTDs, which are kind of the declarations for the XML to follow. So if you save this on your server in your web directory where it is publicly available, we have entity data system, which says which file we want to retrieve. We want to retrieve the windows/win.ini file because this is a Windows server. And we say after that entity param1 exfil system website and data. So we have the data here that is going to be sent to this server with the data parameter here in the request. So this is our server. If we launch netcat on it, we are going to receive the content of the internal file that we inputted. So you can clearly see here entity system equal. This is my website slash the DTG we created. And so as you can see here, we asked to exfil the data to our website. And this is what the application does. It gives back the data to our server. This is the first line of the windows.ini file. Is it clear for now? Because this is going to be a little more complex. Do anyone have any question before we continue further?
Yeah, I was just wondering, so obviously with the burp tool, you change the content type. Have you ever had to manually change the content type header, or maybe kept it as a JSON content type header, but still given it XML format?
Oh, thank you for the question. Nicely, this extension does everything automatically. So all you have to do is just extension, convert. For example, you can see, I'm not sure if you can see very good because I feel like it's small. So it's application JSON here. And if you do extension convert to XML, opla, it's XML directly.
Yeah, I was just wondering if you've ever kept it as JSON before, because just in case, say, a WAF will say no to having that content type header.
Oh, so this is another, these are another cases, but usually when you just have some JSON data that are getting posted, just try to change it to XML and check if it's getting processed or not. If you get the same output from the JSON and from the XML, so it means that the server successfully processes XML data. So you know that you can take the XML data and try to construct a payload to adapt to it.
Okay, thank you.
Welcome. So now we are going to check another vulnerability, which, opla, why does it keep going back to the first slide every? Okay, so we were here. So I had this popular website used by a ton of users daily, which allowed me to upload images. In my Burpsuite folder, I have created a folder which contains multiple upload attacks to check against web platforms. Upon uploading my image file, I got a hit back to my server. So further analysis needed. So how does my file looks like? Why did it come to this? Yeah, so I need a way to not go back every time we do. Okay. Ah, so we have a solution. So how does my image file looks? Because it's really, really interesting that it triggered an HTTP request by the server side. Sorry, it's a little confusing application. Okay. So this is my file. As you can see, my file is a normal JPEG file, which contains a XML payload in the header. So you can see here docchip root public and my burp collaborator link here inside the metadata. If you want this file, I can send it over to you and you can edit the burp collaborator with yours one in case you can't construct it yourself. So I've had that external callback. How can I read secrets on this server? This is the payload inserted in the image metadata. It says docchip element any system, and we have this, which is my website. And I had to set an exact number of shards in my request because the application was only accepting a certain byte of like a really strict number of bytes for the file. So I had to make it match the application's requirements by adding random shards in my file name. And so we have this XML payload, which is going to call two parameters, which are sp param and also xfill. So we have here on my server, first, the, how to say, the AWS endpoint, which everyone knows 169.254, and we have xfill system data. So we say to the XML that once you are going to connect and take this file, which is my external DTG, you are going to make a request to the AWS endpoint, and you are going to send me the data by making an xfill request, by making a system request to my burp collaborator link, including the data parsed from the AWS metadata API. So let's see, this is the live POC of the exploitation. You can see what happens in live in this exploitation. Okay, so to break down, you can see here my file, my GGG file is exactly what we have seen. And here I'm monitoring the requests sent to my server. So I can see that the application is taking my file here. And so I'm sending, as soon as I upload the image, I refresh my burp collaborator server and I get the callback from the hostname endpoint here saying EP IP 172 etc. dot internal. Okay, so we have two questions that came up. How did you know about the length being checked, and how you figured out the exact required bytes for the file? So to break it into parts, let me see if I have the file here. Okay, I'm not sure where I put the file. So let's try to inject. Okay, let's do it live to inject it. To inject, let's take this too many files. Okay, I have this file. I'm going to copy it to testing. So we have this file here. And this is the hex of the file. So to construct your own file, you will have to use a hex editor, obviously, where you will be able to insert your payloads into the first line of the file without breaking the syntax of the file. So it's pretty easy. So for example, if you have to inject something like, let's say, a XSS payload, you just have this. And what you do is just copy it, making sure you're starting here and pasting it. And now you can delete the old code if needed. So you just inject. How you figured, yeah, how did you know about the lengths being checked? I knew about the lengths being checked because once the application was being like more than a certain number of bytes or less than a certain number of bytes, it will just not process it. So it just says, sorry, the file is too big, or sorry, the file is too small. How do you figure out the exact required file? I just must try to upload many files based on the documentation. So for example, let's say you have a website which lets you upload a logo. Okay, let's say a logo, for example. So if you can't find a file which will fit in the logo field, just go to another people's page and copy his logo and upload it on your own. So if he was able to upload it on his page, it means that his logo was good, for example. So you just can take his logo and upload it, and then work to inject your payloads in the files that fit in the system. Okay. So takeaway, XCC can be present anywhere. Look for editor input that accept XML, include your application in which process files, and try to inject payloads in metadata. Thank you. External DTDs are your friends for scratching your XCC. So you have to have a custom, as I always say again and again, you have to have a folder where you put your payloads, which you can mass spray in case you think that there is a vulnerable functionality somewhere. For example, let's check my x6e file here. These are my XML payloads that I took from GitHub and other sources. And so I have, for example, you can see here, replaceme.com. So using burp suite's match and replace functionality, I can just use burp intruder with this list and just like replace this with my burp collaborator link. And just in case there is a vulnerable place, one of these payloads should be working. It's not possible that it is vulnerable, it is like 100% vulnerable, and that you don't get any hits with all this payload. Like it's impossible. So you have to get a good list of payloads because it will help you match later on. Let me just paste this file data in the Slack. So if anyone wants to copy it, you're welcome. Sorry, it's taking much time to paste it because Slack says the file is too big. Um, okay, we can't even create files on this Slack. So anyone wants this payload? Yeah. Hey, oh, I'm not on the same. Let me check here. Can we on Slack? On Zoom, sorry. Yeah, on Slack. Let's do it. Yeah. Better idea. So it's going to get uploaded and we can go on. Yeah. So we are going for the X6E lab. Do anyone have any question specific to what we have covered before we start the lab? Not sure. Yeah, I think you should have got the file now. Yeah. Shivam is all about WAF. So in the file that I just shared, you have multiple payloads that are going to break through WAFs, and so mostly by using external and local DTTs. And for XXE, usually WAFs are very hard to bypass. They are not easy at all. Because if, for example, the word system is blacklisted, you're dead. So you have, if, for example, entity sorry is blacklisted, you know that you can't do anything about the vulnerability. So you might have other cases where you can use UTF-8 encoding against also UTF-7 encodings to bypass the WAF, but it's not common anymore. All the servers were. Can you inject a command inside system for bypass it? No, you can't inject any command inside the system. You can't. You just have to take it like that, and usually use. So one bad thing I did here is naming them XXC, 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 XXC. But usually if a WAF sees XXC in the request, he's just going to drop it. So I suggest you to just change all these names. And I'm not sure where I will find out where I took this payload and share the link in the Slack. I don't remember anymore, but I'm sure I took it from someone on GitHub. So before we go for the lab, anyone else have a question? Looks like not. Okay. So are going to start the lab here. So everyone has had the lab link, and you can try to find the vulnerability in there. I think 10 minutes should be a good time. Everyone's on it? Okay. Okay, good luck. Let me just get water. Is anyone done? Okay, nice. This is Zion, the first time you talk in this lab. I haven't heard from Nirmal, from Arbin. I haven't heard from Robert. I haven't heard anything from Luis. I haven't heard anything from Ayush. Can you guys talk? Don't be shy asking questions. If anything needed, we are here to help. All right. Luis, are you here? I haven't heard you since the start. Okay, man. Okay, happy to have you. So we have does anyone needs 5 more minutes to complete the lab? Try to complete it. Can add up 5 minutes. Okay, Ayush, sure. This is my preferred field. But Ayush, we are here to learn. So if you have any question about XXE, if there's anything that you need help with, we can. Yes, Shah. So I have done it live. I'm not sure if you were following, but let's do it again if you need. So yeah, no worries. Yeah, it's okay. Don't worry. So we have here CD testing. Okay. So we have here a valid image file, which is xg.jpg. Can you see my screen, Shah? Okay. Let's go step by step. So we have this valid image here, which shows this. This is when someone drops a bad music. I just posted to his feed. So you have to open using a hex editor. You can see every hex data here. So we are going to use ghex to edit the file. And you're able to insert XML metadata through, yeah, sure, GB, sorry for that. So we used ghex on Ubuntu to open up the file and try to see the hex content. And from here, from the first line, you can include any payload you want and not break the image syntax. So here you have just to paste. For example, if we take this payload, just copy it, hopla, paste it, and you're good. You can then delete the unwanted data, like here. We had this, hopla, and just file save. And if we refresh here after saving, we can see that the image is still valid. The image is still valid. And if we look into the source, we can see here the XXC payload in the image is injected, and the image is still a valid image. So it's going to pass through the checking of images metadata, because we still have here, you know, this is a JPEG checking. So once a server checks a file's metadata, if it finds this on the starting, it considers the files as an image. So we don't have any problem. And we just let it run it a bunch, and we add our payload later here. If needed, let me upload this file for you. I'm not sure if Slack will detect. I'm not sure if Slack is going to, yeah, let's see. Hopla, let's see source code. Okay, even Slack doesn't. Yeah, you can see that Slack trimmed a little bit of our output here. So we had this, and Slack compressed the file to remove some of our payloads. So you can just take this file and start injecting your payload from here. Yeah, does it make sense? Yeah, you can just add up your payload here. Sure. So let me read again. There was, okay. Shivam says, tried with the XXC payload, but seems like different payload is required since it's already accepting XML data. Yes. Oh, nice. Okay. So we can go through the lab now live to see how and why it happens. And I will show you how I usually take the approach to find the XXC vulnerabilities. So let's open up here. Let me close this, close this, close this, close this. Okay, access the lab. Yes. Yeah. This one, this is the live exploitation for this bug. This was a program on HackerOne. And you can see here, sorry, let me. So this is an actual real report. This is not a lab. I've taken it from one of my POCs. And if you look here, you can see the image here, the GPG. So later on, you can check it again if needed. Okay, so let's see. Oh, what was my password and what was my email. Let's create an account quick. Mm. What do we have? Oh, I can use your link, you think? Let me try. Yeah, it would be good if I can. Oh, okay, so it works. Yeah, thank you. So let's add this to Burp Suite scope so we can intercept requests to. So let's see how it works usually. So the first thing you have to do when trying to attack a web server, of course, is having a tool to check all the requests that are being made to the server. It doesn't matter if it's Burp Suite or Zap Proxy or Fiddler or any other proxy tool. Just have something handy to just catch all these requests that are being sent. We don't want it to intercept this. Let's cancel it. Okay. So I am right now intercepting requests and I'm going to click here, for example. I know that we're looking for XXC, so I'm looking for something that has XML data. Let's click here and you can see, oops, there is actually the XML data. So this is the XML data that we have. The first thing I usually do is going to a website that has many references to many different payloads, because it's not, there is no like worse in remembering a complete XXC payload. It's not that helpful because you can grab it like in a second from anywhere you want. So just understand how it works is better than having like payloads in memory. So the best resources for me about all kind of vulnerabilities is the github.com. Yeah, payload, all these things, XXC. So where is my browser? Sorry. Second. So we have here the payload, all these things, GitHub page. This one is for XXC and it contains a ton and a ton and a ton and a ton of resources and payloads. So every time you get lost or you need help or you need to exploit something, just come back to the payload or the things GitHub page and get ideas and get payloads to try against your target. So as we can see here, we have a path to products as stock, and we can see there is XML data being parsed. And so first thing we have to do is to try for the replace. We have to try for the replace thing. So we have here docchip replace. We have here the output is 17, all right? So we are going to, okay, get me back project ID 2, sorry. Okay, this shouldn't give any error. This should still work. And now, instead of project equal to, let's call replace here. And this should still docchip replace entity example 2 seconds, please. So XML parser existed with non-zero code. What's happening on my Slack here? Sorry. Yeah, sorry. So we have here and you have here call the example and invalid project 2. So we had 2, and if we send it, we have the G17. Not sure what's happening on my Slack here. It's like still okay. It's working now. So we have again the 17 output we input. So that's cool, but we need to find a more we need to exploit this. So the first thing you have to do is try to load an external local file. So for example, here, if you look up, we have to check for exploiting XXE to retrieve files. Yeah, example it was, sorry. So now we have confirmed that the form is parsing XML data. We can try to read local files as part of our attacks to make it more to prove that the vulnerability exists in case of bug bounties and stuff. No team will accept a simple, how to say, a simple replace. So what we should try to do now you have here an example of payload. You can just copy and try to play along with it. So instead of the docchip replace function we had, we can just try this thing we had along with test. We are going to call to try and see what output we get. And what we get obviously is the local file content that is being sent back to us. So what you have to do always is go back to these pages and try to check if any of the payloads is going to work on your target, on your endpoint. So you have many ideas enabling, so even for kind of billion loaf attack and DOS and everything error-based. So go back every time when you need help, when you don't find a solution to your problem. This will render, this gave us back the content of the local file, because it says invalid product ID, and we said the product ID is located at the local file at /etc/password. So the file is going to get loaded here, which says that this file ID is not valid. And as the application is giving us debug info about files, so this is what happens here. So I guess this one was easy and everyone got it very quick. And now we are going to move to another module, which is server-side request forgeries. And don't worry, we are going to have more labs at the end where we can more hacks and talk. So we are going to exploit more deep functionalities about each vulnerability, so everyone can get more time hacking. Let's just take some time at first to explore everything that is around each vulnerability and see how things work. So we are here. Does anyone have questions before we continue on? Yeah, of course. Is it time for break? How much time is the break supposed to be? Sorry, I don't have the agenda here. I guess. Okay, so it's going to be 1 hour break, right? Welcome back, everyone. And let's start ahead with the topic that we closed on. So now we stopped on server-side request forgeries. So this is going to be a really interesting topic to talk about. And I want everyone to take notes and to ask questions about everything that you need to know. Because if you are all here and you have paid to be here, it's to, at the end of the day, it's to benefit from knowledge. And I think it's the best time to ask questions is once we end the topic, or if you don't understand something while we explain, please don't refrain from asking, just ask, don't be shy. Just going to take a minute to explain, and so everyone can benefit from the course. So we are at server-side request forgeries. So what is a SSRF, aka server-side request forgery? Server-side request forgery from Perstrigger is a web security vulnerability that allows an attacker to induce the server-side application to make HTTP request to an arbitrary domain of the attacker choosing. So when we go forward, just want to make sure everyone can see the screen and everyone is following me? Thank you, Neo, for the response. Okay. Perfect. Perfect. So what to do when I find a SSRF? The first thing you should try to do when you find a SSRF is trying to access local files just as it was like a local file inclusion. So instead of loading the HTTP protocol to make a request to an external or internal web server, try to hit an internal file. So by using the file protocol you can see here. So this is the first thing, and in case it works, you just escalated a SSRF easily and fastly and cleanly. The second thing you might try to do in case you don't find, in case the file protocol is not usable, you should try to load to steal cloud secrets such as AWS EC2 and Google Cloud secrets from the metadata API. Third thing you should do is to try to port scan and discover internal hosts. And the last thing is to try to access any kind of private content. So when we have SSRF, we want to show the max impact to the teams. It's just not like about showing, okay, I'm able to make a request from your server to my server, so this is a bug. It's just not enough to confirm that it's a critical vulnerability. Going forward, where to find server-side request forgeries? Mostly in every parameter that takes a URL as input and returns content of the submitted URL. Pay attention, if you can abuse application request functionality, you will go out of scope. So if an application just make a request because it has to make a request, for example, to fetch an image or to fetch a specific content, if you can't abuse the functionality and you report the vulnerability, you're just going to go out of scope, and it's not what we want to do. So you have to make sure that you can abuse the vulnerability before submitting it to any program. So you can find also SSRF, as you have seen in the previous topics, you can find server-side request forgeries by using XXs. And so you can also find server-side request forgeries using other vulnerabilities. The most interesting part about SSRF is that you can chain things. You can chain many little vulnerabilities into a complete part just to hit the most the highest impact you can. So for example, you can chain an open redirect with server-side request forgery to bypass domain-based restrictions. What does that mean? Let's say, for example, you have example.com/ssrf.php and the URL parameter. So the URL parameter does fetch content, but it does fetch content only from the same domain, so only from example.com. So you can't do, for example, URL equal google.com, it won't work. So what we want to do is to find an open redirect on example.com and then redirect the vulnerable endpoint to our external server. So the script is going to try to fetch this content, which it does because it's on the same domain, and this content is going to redirect to our external server. So this is where the main application is going to fetch the response from. You can chain also CRLF with SSRF. So for example, if you have example.com and the same file again and the same URL parameter, we can sometime do for example, URL equal test and the CRLF payload, including host attacker.com. So how will this go? This will go as the server is going to make a request to this endpoint, which is test, and it's going to add the host parameter to attacker's endpoint. So at the end of the day, the application is going to make a request to attacker.com/test instead of the main website it's hosted on. Is everything clear for now? Okay, awesome. So we can, yes, of course. The open redirect parameter depends on the open redirect that you have. Yeah, CRLF works sometime, depends on libraries that are on the backend. So let's go forward and explore more. So most of the time in bug bounties, you have the local host, which is blacklisted, but we have ways to bypass the restriction in places. So we can use these payloads to try to bypass the local host, which is blocked. Sometimes you might get lucky and it might work, and sometimes it might just get blocked, just as localhost plain text link. These are some payloads you should start testing on your targets, and especially this one, which I've had much success with the time, because even if it's localhost, the application doesn't check the final link, the final string, but it's going to just decode this one to the ASCII and make a request to the corresponding link. Let's go forward and see what's happened. So we have also CGIR bypasses. We can use this one or this one or this one. And you also have decimal bypasses, which work sometimes, depends on libraries, mostly on curl. This works when there is curl on the backend. And you also can try the hexadecimal bypasses, which are here. Going forward, we can also bypass server-side request forgeries using DNS tricks. This means that we might be able to use DNS rebinding techniques. What is DNS rebinding technique? So for example, let's take this host. Let's take this host, for example. We have this host which has a DNS rebinding service set on it. Let's see what happens when we do, for example, host this.
Hey, do
So,
you mind making the text a little bit bigger, if that's possible, please?
bigger?
Yeah. Oh, yeah, because I'm on my phone, so it's really hard to see that.
Yeah. Let me see how I can figure this out.
I think it's just Command and plus. That should be okay.
The plus you said?
Command and plus.
Command and plus, no, doesn't work.
Oh,
It should be here from the settings, but no problem. I can figure this out.
sorry about that.
No worries, man. It's okay. So we should have general. Let me find. Okay, so I guess it's here. Let's try like this one. Okay. Is it better for you?
That's great. That's way better. Thank you.
You're welcome. Okay, so we've had this host which has DNS rebinding technique set on it. Sorry, everyone can see the terminal? Yes, okay. So let's see what happens when we do host and this host. So the first address that is returned is obviously 169.254. This is the metadata IP addresses on cloud endpoints. Everyone knows it. What happens if we do again a host? It's still the same. What happens if we do it fastly? You can see here, we've had, it was address to the metadata API, and then address changed to 1.2.3.4. What does this mean? This means that sometime when you try to find server-side request forgeries, the application you are testing is going to try to make a to check the final resolution of the domain you input, and in case it matches a blacklisted IP address, it's just going to tell you, oops, you can't add this website here. So this trick works to bypass this kind of restrictions, because in case you insert the website when the IP address is set to 1234, as this is not blacklisted on the application, it's going to go through. But later on, once the application tries to fetch content from this same domain we input, it's going to try to fetch content from the other IP, which is the AWS metadata API. So the first thing that was blacklisted, which was this, is going to end up being whitelisted because the server thinks this was our initial IP address, which is not blacklisted. Does this make sense to everyone? All right. So going forward, we were here. Sorry, Ayush, do you want me to repeat again? Okay. So let's see here. You have this website. Okay. This domain is going to act as a DNS rebinder service. What does this mean? This means that if you check the DNS of this URL, at some point it will be 1.2.3.4, and at some point it will be the AWS API address. So sometime when you try to input a website or just a link on a website, it's going to check for the DNS of the domain you input. So in case, for example, you input this domain and the API and the DNS point to this IP address, it's mostly blacklisted because this is internal endpoints for cloud services. So it's not going to pass through. You are going to have whatever error from the application. But in case you input this domain while the NS points to this IP address, which is not blacklisted, it's going to go through. But the thing is that the the name server of this domain we just added to the application is changing each minute to one time to this, one time to this. And so it's going to round between the both. So at first, when the application accepted our submitted domain, the name server was this one, but later on, when we try to use the service, the new IP is now this one. So in case we can retrieve data from this domain, which the server thinks it's this IP, then we can hit this. Does it make sense now? Okay. Sure. So let's go on and continue where we were. Domain redirections. So everyone might know this trick already. It's like pointing a website to localhost and just adding it to the application, to the SSRF function we are trying to test. Sometimes it works, sometimes it doesn't work. So let's go forward. We have other bypasses. We have bypass using enclosed alphanumerics. So at some point, I have found some forms which will take this, as you can see here, which says example.com, and it's going to convert it to string example.com and make a request to it. So sometimes you might be able to construct like a 1 to 2. For example, let's take again the website I've shown you, the Unicode. And you can try here on coding your payload. For example, let's say you want to access AWS internal, just have to make this. And here you have many encodings for it that are available that you can try against your SSRF endpoints when the plain text is blacklisted. So this might pass some time if there is no check of the final destination of the inputted domain. Does this one make sense to everyone? Perfect. Let's go forward and see. So we have also bypasses using 301 redirects. So just pointing a PHP script to redirect to localhost or any other language that you prefer. Okay, so let's go for real world attacks. Let's explore a bunch of reported SSRFs in bug bounty programs. Case 1, SSRF in webhook. So we're all okay. The most tested functionality for server-side request forgery by bug bounty hunters is the SSRF in webhooks, because you know that this is going to make a request to somewhere, but you just don't know if you can still abuse this to make request to something. So you try to abuse it and try to exploit it. So the application I was testing had a webhook test function where user can input a URL and test the connection to the server by displaying the content of the requested link. So first of all, I always set any link to my Burp collaborator server. After getting the hit, I copy the IP address that sent the request and check on ipinfo.io the location of the server. Is it AWS? Is it G-Cloud? Is it some kind of internal host? So for my case, the server was located on Amazon. So if we can control the request, we might be able to read internal secrets from the cloud API. The procedure of testing I took. So testing, the first thing I did is sending a request to the webhook. Sorry, with the URL set to my Burp collaborator domain. So this way I can see what user agent is making the request, or what IP is the server's application coming from. So I have some details to start testing for real bypasses. So the server sends a request to burp collab/webhook, and notice the server adds webhook at the end of the URL. What does this mean? This means that every time I do this post request, so every time I do this post request, the server is going to add /webhook to the link automatically. So this is something we should note for bypasses. If we go forward and we see what happens, I tried hitching AWS API. The server responded with a 403 error. IP is blacklisted. So we used the DNS rebinding technique we just talked about on this, and the server responds with 404 not found. So what does this mean? This means that this domain was blacklisted, and we were able to bypass it by using this domain. And now we are getting 404 because the server is default adding /webhook to the end of the URL, which is a 404 on Amazon cloud IPs. So using DNS bridging, we're able to bypass AWS EC2 IP blacklist. One more thing to bypass is the webhook that gets added to the request deliberately. So if I input google.com, the server is going to output google.com/webhook. We can use multiple chars such as this chars and null byte. Remember that AWS will always drop everything after null byte in request to its internal API. This is really interesting to know because you might need it sometime with any kind of bug when you're hacking on a target which is located on Amazon EC2. So proof of concept. I sent a post request to /API webhook with the URL with the DNS rebinding host, and I'm adding the path I want to hit, along with at the end this char, which is going to drop the /webhook that gets added to the URL by default. So, do anyone have a question on this one? It depends. It depends on cases. So, do you mean like setting one IP to your domain and one IP to another private endpoint like Amazon? Okay, so let's continue. Case 2, SSRF accessing file protocol. Application takes link and returns screenshot. How many times have you seen an application take a link and sends you back a screenshot? These are the best places to look into. Yes, Shivam. Yes, Shivam, it might work. It depends on the environment and how everything is set on the backend. So, for this case, the application takes a link and it gives you back a screenshot of the link. So if I try to input file etc/password, the application took a screenshot of this path and sent me back the screenshot containing the password here, password file. So case 3, server-side request forgeries via cross-site scriptings in PGF renderers. Have anyone heard of XSS and elevating XSS in PDF forms? Okay. Okay. So sometime there are some application where you have an export PDF feature. What this functionality is going to do is that it's going to export one of the functions that you have in the panel to PDF. And for example, let's say, for example, you go to a website and you buy a product from it. Okay, let's say you buy a product from a website. You go to your account and you see how to say invoices, and you find that the invoice is in PDF format. Okay, so this means that the application is creating an invoice with a PDF format based on the billing and your account information. Is it clear to hear? Can we go forward? Okay, so let's say the invoice looks something like that. Let's say invoice number to Hussein, let's say to Hussein, and it says product, etc., price. Okay, let's say the invoice looks like this in the PDF. This means that my name here, which should be my name on the website, is getting sent to the PDF renderer. So in case we are able to find a cross-site scripting in the flow of the application, we might be able to access internal application and make SSRF alive. So now that you have spotted that your name is getting reflected, you go to your profile stat setting, for example, and you find name settings. Okay, so at this point, let's say, for example, you try to input a basic HTML tag, and after that, you go and you try to export again your invoice. And this time, instead of seeing Hussein, you are going to see the XXX with like an arrow on it. So it means that it's dead. So is it clear now? Okay. So I had an XSS in an application. So I had the XSS in an application, but I wanted to escalate it further. After mapping out the application more, I found that there was a PDF export feature, which would render content we input into the web application along with a custom template. Okay, let's see what does this mean. So the first test is going just to try to hit my Burp collaborator as every time and checking if I get a callback. So when I added my BIP collaborator link here, I got an instant callback from the company. And so I got a callback from the domain here. Sorry, where are we? So this means that script tags are getting accepted in the PGF renderer. So the PGF usually takes the input and tries to parse it into backend and try to give you out the result in the PGF format. So after exporting the PGF, I received a callback to my BIP collaborator server. This means that JavaScript is being executed on the PGF exporter. And this is where it gets interesting. So here, let me just check. Okay. Okay, this means that JavaScript is being executed on the domain. That gets more interesting. So I created the file test.php on my server, and this test.php contains this PHP code, which is a basic redirect to /etc/password. So here, created a file test.php on my web server, which contains the following code. So going to test.php on any server Cynac should return this. Again, so now instead of using script tags as we did previously, we're going to use iframe tags, which I think is not a good option for you right now. So sorry, I'm not sure why it gets like every time it gets. So do you get the PHP file trick yet? Okay, so this file is going to redirect to /etc/password file. So in case we are able to make the server hit our PHP file, it's going to get redirected to internal service. So in our case, nothing was rendered because server wouldn't load files on my server. It's okay. So again, as we talk about open redirections, I found an open redirection on /logout /redirect to attacker.com. So I used this payload in our XSS field to have a final payload, which looks like this: iframe src API /logout redirect to equal attacker.com/test.php. So what this means is that we are going to iframe all this, but all this resolves to only the last page here, which is going to send us to the internal files. And this is an example of what I'm talking about. You can see here in the PGF that I received from the company, you can see here the password file inserted via iframe. Can we go forward, or does anyone have any request here? Okay. So takeaway, be creative with server-side request surgery. You can literally go from 0 to hero, save open redirects and serverless for this kind of exploitations. So, all right, let's do a lab, everyone. Let's make a lab. I'm sending a link to here. Yes, sure. Go on, I'm hearing you. Okay, makes sense. If anyone has questions, please drop them now so we can process all the questions because before we go to the labs. Okay, so first question, what can we do when we get only DNS responses in Burp Collaborator? So when you get DNS response in Burp Collaborator, that mostly means that the website blacklisted external hits, but it does check for the name server anyways. So that's why you get the NS symbol on Burp Suite. So this one is really relative. Next question, it says, are there any other parameters we need to look for as server-side request forgeries apart from URL and file parameters? So you have mostly links, file parameters. You also can maybe it depends. I mean, you might be able to inject into the plain how to say header, but it's a little risky for the security. So let's just wait for it. And 3. Sure. 3. How can we exploit server-side request forgeries using open redirect vulnerabilities? You can exploit SSRF using open redirect vulnerability when you actually need an open redirect vulnerability on the website. So you use the SSRF to hit the redirect endpoint. Yeah. Sorry. Do you mean? Yes, you can try SSRF with Gopher and with other protocol like Java, File, and NetDoc, but it really depends on the application that's making the requests. Yes, I'm going to give you a server-side request forgery script that I coded for you. So before we go to the lab, let's check out the tool that I have made for you so you can start using it on your future targets. So let's see our script. So this is the, sorry, it's not. So, okay. Um, so let's check out this tool I have made for this talk. So we have this tool called ssrf.sh. This tool uses wayback URLs and GAU to gather links from the services, and it's going to try to add multiple parameters to this to the links, and it's going to try to send a request to each of the endpoint. So let's take, for example, let's say, okay, bash srf.sh, you have to need a burp collaborator link, and you have to do, for example, example.com, and you input the link of the okay. And you see, it's going to get wayback URLs from the database. Then it's going to get the GAU links. And after that, it's going to send the request with the burp collaborator we've seen. So I'm just going to send you this. Do you often find SSR with this script? I often find server-side request forgeries with this script that are not authenticated, and sometimes it's hard to try to take it further, but yeah, I've had some luck. So it depends. So to use it, you have to have FUF installed, and you will need to have a GAU, and you will need to have wayback URLs. Let me see if I can send it here. Yeah, so everyone can go and save this one if you want to use it in the future. All right. We are going for the lab now. Everyone can open the lab. I've sent another link, I guess. This one. So can everyone access the the lab. Okay. So I'm going to give you 10 minutes to find the bug. Yeah, you're right. I'm going to send it to the other Slack. Sorry. Yes, forward. Yes. I've had some luck. But of course, you will always end up finding more vulnerabilities when you are authenticated. Yes, Kunaj, you can do whatever you want. Let me check the link, Peter. No, there is no commands on the code, but you can try it right away. And if you have any error from the script, you can tell me and I will try to fix it for you now. Oh, Peter, I'm trying to load the link you sent me. Let me try to open it on my other computer. Sorry, Prashant, I think your mic is on and there is noise behind you. Okay, so I could mute you. Okay, so Peter, the links, the tool you sent the link to looks like a good setup, but I feel like sending the request with curl is going to have too much resource usage on the computer. So too much CPU, too much power needed, while FUF is coded in Golang, so it's very fast and it's smoother. So let's see here if we run the script really fast on any target. Let's see, for example, I don't know, something that doesn't have much results, just to check. Okay, let's try example.com. And you have this. Okay, so let's try this. Yes, of course, Peter. Yes, you can reduce the concurrency I set on the tool to not get blocked. So have you tried to solve the lab? Okay, so you can see here what's happening on the script. No, Tizion, in real life, in real bug bounties, sometimes when you're able to access localhost, sometimes you have application which doesn't need authentication, and sometimes you have application which need authorization. So it's about being lucky. So if you're lucky, you might end up finding an endpoint that doesn't need any authorizations, and you might be able to just make like a critical bug out of your server-side request forgery. Welcome. Okay, so let's let this run in the background, and let's try to solve this meanwhile. So we are here. What I'm going to do is, first thing, I'm going to add this to my Burp Suite scope. And let's see how it starts. So I started by looking at robots to see if there is directory. There is no robots. Okay. So command passes, maybe login. There is login, maybe admin. Oh, we can't access admin. So my account, I guess there should be some credentials that should be given. Um, Okay, so let's see what happens here. If we go to details, we have some requests. We need to find something that looks like it's making, okay, a request to a link. So let's put this here. First thing you want to do is to copy your burp suite and try to check if this accepts connections to external hosts. And so we can see that the requests are getting sent to our host. This means that this parameter is indeed trying to load a file somewhere. So we can try to load localhost to check. If we go to this, okay, so we have the same application. And remember that we tried to access /admin, but it was blacklisted for us. Let's try to access it using the server-side request forgery. Yes, Shivam, sure. And we can see that there is a link here which is used to delete users. So if we just copy this here over here, we can see that it worked. And user deleted successfully. So this is how we abuse server-side request forgeries to make internal requests and access internal endpoints. Do anyone have question on this lab? If there is no pingback on the burp collaborator, this means that the server has a whitelist. Yeah, this means that the server has a whitelist for allowed hosts. So you might try links like, for example, allowed hosts at and your burp collaborator link and check if you get the response. And you can see that we can get the response from the burp collaborator here. We bypassed this. So using the trick, we were able to bypass the allowed hosts. Do anyone have questions? Okay. Okay, so how long often do you spend on hacking a single program before moving to the next program? So in the past, when I started, when I started Bug Bounty, and even like 2 or 3 years from now, every time I choose a target, I used to just switch to other programs very fast. So it's like, okay, I hack on this today, and tomorrow I'm on another program, and then I'm changing program again. But that's not something that's good. Today, when I take a program, I try to focus at least for 2 weeks on the same program before changing. Abida says, what is the purpose of SMTP pinging perp collab? Abida, this is when a server sends a mail to your burp collaborator server. Yeah. So Abida, it's mostly when the server tries to send a mail to the burp collaborator server as a mail host. No, it's not. It's definitely not. It's, for example, let's see here what's happened. Let's go to, for example, so if you try to sign up with the burp collaborator address, you're going to get the same SMTP pings that you have seen. So it's slow now, but you will see it. So it's not vulnerable, no. Yeah, it's like the server is sending a mail to your burp collaborator server, just a mail. So nothing really sensitive. Any questions before we continue? When I test a bug bounty program and I'm out of ideas, I just keep looking and looking again at stuff with a different perspective. So it's like I come back to hack on this same program, but with another mindset, and trying to find endpoints, at least endpoints or other subdomains, for example, that I haven't had on that program. So I'm trying to, to expand my attack surface, because if you have more attack surface, you know that you can spend more time hacking on multiple targets. Welcome. Okay, anyone has a question? Okay, so we can go on. Yeah, Ayush. We can go on with remote command execution.